In this video, we will continue with trigonometric graph sketching. You will find this on page 163 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. Let's look at another example. State the period p of the function fx equals 5 tan 4x. Sketch the graph of fx equals 5 tan 4x. For x bigger and smaller, bigger and equal to 0 and smaller and equal to p. Okay. Now, what is the period? So the period, I look at this value. You see there? Okay. Now, I know a normal one. If you just have a normal tan x, 1x, then I know it's always going to be the period 180. For the sin and the cosine, 360, but the normal, 180. So that is where the 180 comes from. And then, but now it's 4, so now I divide it by 4. If it was 5, I will divide it by 5. So I get 45 degrees. Okay, so that is the period. Now, I go on. Sketch the graph of this. So in the y equals tan, the graph of the asymptote is 90. That's a normal. That is the period of a normal one. And the asymptote of a normal tan graph is 90. And I can even, I just hope I'm going to be forced to see that. I would like if you could see a normal one. Okay, here it is. Let's go bigger. Okay, can you see there? There was the 90 and then the negative 90 and the 270. But that was the normal tan x graph. Okay, so I'm working from this normal one. Let's go on. Okay, still on. Okay, still on. Okay, so the normal is 90. So the graph is undefined when 4x equals 90. So now, if it's 4x, I put the 4x equal 90. If it was 5x, I would have said 5x equals 90. So the asymptote will now be where x is 22.5. Did you see how I got the new asymptote? So set up a table for some key points in the range. I think especially for a tan, it's always good to assist you with a table. Okay, so it will help with the construction of the graph, especially for the tangent function. They just wanted to p, and p was the state the period. So they just want it up to 45. And now you just divide. You can make it a bit smaller so that you have a more accurate graph. So let's make it 10, 15, 20, 22.5 there, 25, 30, 45. Now, very important. You have to remember to set the calculator to degree mode because you are now in degrees. So then you're just going to put that into that 0. So you're going to press into that function. 5 multiplied tan 4 times 0. So it's actually tan 0 and it's 0. And now you put in the place of x 10. Okay, but just remember, and I'm just going to put my calculator. I press 2 times mode and then I press the 1 for degrees. And so for this one, I'm just going to show you one, say 10. So I'm just writing it like this. What is my function? My function is fx equals 5 tan 4x. And now I'm just going to put a 10. Oh, sorry. So it's going to be 5 multiply tan 40. And that, make it one decimal place, 4.2. All in the one. And this one, you can test it. It's just going to give you an error. So if you put there, let me just make it smaller. And you can test it, and this is just showing you the asymptote. If you put there 22.5, and you press again, 5 multiply, where am I now? Tan, bracket, 4 multiply 22.5, close the bracket, equals, it gives you maths error. And that indicates that it is undefined. Undefined. Like that. Indicate the asymptote. Okay. And then you start again and you plot your points and you know that the curve, you must, it's always very important, especially in this graphs, that you remember how does a normal tan x graph look? How does a normal sin x graph look? How does a normal cosine x graph look? Because the basic form is staying the same. It can just be stretched out, or it can be a little bit compressed, or it can be shift up, or it can be shift down, something like that. Okay, I want you to stop the video and I just want you to do number 1. Okay, and then as soon as you are finished, you can continue the video. Okay, let's start with number 1. State the period P of the graph. So let's just write down the graph. And 6x. Okay, now let's do it just exactly like the previous one. The period of a normal y equals tan x graph is 180. That's the period. Okay. Don't forget, a sin x graph is 360 and a cos x graph is 360, but a tan is 180. So that's why I'm going to say, I take one to find the value of P, I take 180, the period, and I divide it by 6, and I get 30 degrees. So therefore, the value of P is equal to 30 degrees, and that is indicating the period. Okay, so that means also when the graph will start to repeat itself. Okay, so it will make one full cycle, can you almost say. Now, we go on. Sketch the graph until that. So it's only up to 30 degrees. Before we do, because it's tan, we know there are asymptotes. So how do we get the asymptote? So we're going to start with, that was number A, number B. So so the asymptote of a normal y equals tan. So that's the period. Let me just write, and 90 degrees is the asymptote. Okay, so therefore, I'm going to say, okay, to find that, I'm going to take that 6x, because it's not 1x, and I'm going to write it equal to the normal asymptote. And then I divide both sides by 6, and I get, let me just get my pen correct, I get that x is equal to 15 degrees. So therefore, an asymptote at 15 degrees. Keep it in mind, it will be your dotted line. Okay, now we're going to set up a table for some key points in the range from 0 to 30. It will help with the construction of the graph, especially for the tangent function. Remember to set the calculator to degree mode. So let's first construct a small table. And the shorter the spaces, let's just get the table. If I make the spaces not too big, the intervals, let's call it that, then it will help me to get a more accurate graph. Right. But let's start. This is my x. Oh, let's get my pen correct. Still not correct. This is my x, this is my y. Don't forget that I will substitute it in there. So what values? Start with 0. Because they said there from 0. So they mean now from 0 to 30 degrees. So I can think 0, and then I think 10 will be a good one. And then where was the asymptote? The asymptote was at 15. So 15 is a good one. I go in 5s. And then I can make it 20. And then 25. And then 30. Okay, up to 30. Now, don't forget, and I'm just going to show you the first one. So basically, I'm going to say for the first one, y equals 4. Now, maybe I'll give you more than the first one, because then I just put 0. So basically, and make sure your calculator is on degrees, D. So it's 4 multiply tan 0 equals, and that will be 0. But now, for the next one, make the cleaner, I'm going to put now 10. So 6 times 10 is 60. So it's 4 multiply tan 60 equals. And that will give me an answer of 6.9. And then I do exactly the same. And now I'm putting 15. And you can go and test if I make a stripe like that, indicating the asymptote. And then I'm going to put 20. So I'm just going to be 4 multiply tan. And that will be 120. And that's negative 6.9. And if I do it with 25, I get negative 2.3. And if I do it with 30, I get 0. Okay, now I'm ready to construct. You can still work on, you can work on graph paper, but you can work on paper also. If you work on paper, as I said, when we're drawing graphs, it's very important, and I'm just going to, I have to create a grid. It's important just to work with 1 centimeter blocks. So if I make a grid like this, maybe a little bit longer, I must move it in a little bit up. Okay, and I can work it. Yeah, okay. Oh, it's not good to use a ruler, please. Okay, because it's no negative value. Sorry, I'm taking a bit long to get my graph. Okay. I hope we have enough space there. But because I'm working with negative, I'm actually getting that 0. I can work in 2, so I can work 2, helps me, 4, 6, but always make it 1 centimeter, 8. And then I can go to negative 2, negative 4, negative 6, negative 8. And then I think I'm going to make this a bit wider, 10, 20, and 30. Well, it's not so wide. And then I start with the plotting. So at 0, it's 0. There it is. Okay. And then at 10, it's going to be 6. It's going to be 6.9, so it's almost 7. Okay, it's actually very good if you first go and at 15, so there is 10, there is 20, so 15 will be here. If you first go there and you first create your asymptote, I'm just going to use my ruler again, before you start, that you know that that is your asymptote. In pencil you can make that broken line. Okay, and then okay, that one is then done. So I can actually already draw that one. I will do it now. And then at 20, it's negative 6.9. And at 25, okay, I could have put 5 also in. That would have been nice. I don't know why I didn't put in 5. It would have been nice. So it's negative 2.3. And at 30, it's 0. Because now I struggle. So I think, I sometimes, as soon as you do it, you start realizing, yeah, why didn't I not put this one in? Okay, so let's just make a space. We will struggle a little bit with that space, but we'll make a plan. Okay, so let's just go for that space. And let's just create that 15. Oh, it's again my pen. Not 15, so 5, sorry. The middle of that is 5. And then if I put 5 in here, and I press it on my, so it's 30, so it's going to be 4 multiply tan 30, and that's 2.3. It's actually exactly the same, do you see? But I wanted to show you. So that would have made it then easier if you had 2.3 here. And then I just create. And then for this one, I will create it. Always remember your basic shape. So it's striving towards the asymptote, but don't cross it, then it's incorrect. And if I want to give a nice name to this graph, this is the graph y is equal to 4 tan x. Okay, and that's how you create this graph.